Welcome my dear students to the chapter Mechanical Properties of Solids. In this module, let us discuss about the concepts of stress and strain and Hooke's law. The property of a body to regain its original configuration, that is length, volume or shape, when the deforming forces are removed, is called elasticity. The change in shape or size of a body when external forces act on it is determined by the forces between its atoms or molecules. These short-range atomic forces are called elastic forces. A perfectly elastic body. A body which regains its original configuration immediately and completely after the removal of deforming forces from it is called perfectly elastic body. Quartz and phosphor bronze are the examples of nearly perfectly elastic bodies. Next is the concept of plasticity. The inability of a body to return to its original size and shape even on removal of the deforming force is called plasticity, and such a body is called a plastic body. Now let us discuss about the concept of stress. Stress is defined as the ratio of internal force F produced when the substance is deformed to the area A over which this force acts. In equilibrium, this force is equal in magnitude to the externally applied force. In other words, stress is equivalent to force per unit area or F by A. The SI unit of stress is Newton per square meter. In CGS units, stress is measured in dyne per centimeter square. The dimensional formula of stress is dimension of F divided by dimension of area, which is ml(T raised to minus 2 divided by A square, which is equivalent to ml raised to minus 1 T raised to minus 2. Now let us discuss about the types of stress. There are two types of stress. One is normal stress and the other is tangential stress. Now first let us discuss about normal stress. It is defined as the restoring force per unit area perpendicular to the surface of the body. Normal stress is of two types, tensile stress and compressive stress. Now next is tangential stress. When the elastic restoring force or the deforming force acts parallel to the surface area, the stress is called tangential stress. Now let us discuss about the concept of strain. Strain is defined as the ratio of change in size or shape to the original size or shape. It has no dimensions and it is just a number. Strain is mainly of three types: longitudinal strain, volume strain and shear strain. If the deforming force produces a change in length alone, the strain produced in the body is called longitudinal strain or tensile strain. It is given as longitudinal strain is equivalent to change in length by original length, that is delta L by L. The second type of strain is volumetric strain. If the deforming force produces a change in volume alone, the strain produced in the body is called volumetric strain. It is given as volumetric strain is equivalent to change in volume divided by original volume. which is equivalent to delta V by V. The third type of strain is shear strain. The angle tilt caused in the body due to tangential stress expressed is called shear strain. It is given as shear strain theta is equivalent to delta L by L. The maximum stress to which the body can regain its original status on the removal of the deforming force is called elastic limit. In this picture, you can see longitudinal strain, shearing strain and volume strain. So you can see longitudinal strain is produced by applying a force which is perpendicular to its surface as shown in the figure. In the case of shearing strain or volume strain, the force is applied tangential to the surface. In the case of shearing strain, you can see the angle theta produced by the deformation and also the displacement delta x. Now, let us discuss about Hooke's law. Hooke's law states that within elastic limits, the ratio of stress to the corresponding strain produced is a constant. This constant is called the modulus of elasticity. Thus, modulus of elasticity is equivalent to stress by strain. Since strain is a pure number or a dimensionless quantity, the unit of modulus of elasticity are the same as that of stress. That is, its unit is Newton per meter square. Hope you have got an idea about stress, strain and also modulus of elasticity. Thank you, dear students.